long division logic remains consistent from basic arithmetic into variables and exponents. We use a familiar grid to bring these terms into a structured alignment. We'll demonstrate by dividing 2x cubed plus 3x squared plus 1 by 2x plus 1. Here, the numerator is the dividend and the denominator is the divisor. Remember, our divisor cannot equal 0. By standardizing these terms and following a repeating loop, we create a reliable system to deconstruct the equation without losing track of its algebraic components. To begin, we arrange the dividend's terms in descending order of their exponents. We place the divisor on the outside and the dividend inside the bracket. There is a gap in our dividend between the x squared term and the constant. The x to the first power term is missing. We fill this gap with a placeholder 0. Adding 0x ensures that our columns remain mathematically aligned during the later subtraction steps. The division starts by isolating the leading terms. Dividing 2x cubed by 2x gives us x squared. This monomial becomes the first part of our quotient, which we write above the bracket. Now we distribute that x squared across the entire divisor. Multiplying x squared by 2x plus 1 gives us 2x cubed plus x squared. We align this result directly under the matching terms of our dividend. We move to the subtraction phase. By subtracting the entire expression, we ensure the negative sign applies to both the 2x cubed and the x squared. The leading terms cancel to 0. 3x squared minus x squared leaves 2x squared. We then bring down the remaining terms to form a new working polynomial. We check the degree of this new line. Because the degree of 2x squared is still higher than the degree of our divisor, the algorithm requires us to run the loop again. We restart the sequence by comparing our new leading term to the divisor's leading term. 2x squared divided by 2x is x. We add x to our quotient at the top of the bracket. Again, we multiply this new term by the divisor. X times 2x plus 1 results in 2x squared plus x. We place the new line in brackets and apply the subtraction. The x squared terms cancel. 0x minus x leaves us with negative x. We bring down the final positive 1 to arrive at negative x plus 1. The degree of our current polynomial is 1, which is equal to the degree of our divisor. Since it is not yet strictly less than the divisor's degree, we proceed to one final loop. We divide negative x by 2x. This results in the constant negative 1/2, which we add to the quotient. This introduces a tricky negative fraction into our multiplication step, which completely changes how we must process the final subtraction. Multiplying negative 1/2 across the divisor gives us negative x minus 1/2. When we apply the subtraction brackets, the external minus sign distributes across the line. This converts both internal negative terms into positives. The x terms cancel. Adding 1 and 1/2 leaves us with a final value of 3/2. Maintaining this focus on sign distribution during subtraction is the key to completing the algorithm accurately. We perform the final degree check. A constant has a degree of 0, which is a lower degree than our divisor. With this condition met, the algorithm terminates. We identify 3/2 as our remainder. We format the final result by taking the quotient and adding the remainder over the divisor. So the complete answer is x squared plus x minus 1/2 plus the fraction 3/2 over 2x plus 1. By strictly following this loop, arranging terms, dividing the leads, multiplying, and checking the degree, you can simplify any polynomial fraction.